Why minimize the cross-entropy instead of the classification error? Classification error is the most intuitive measure. It's just 1 minus the correct classify. P hat k is the proportion of the correct classify in class k. The main drawback of the misclassification error is that when p equals half, the function is not differentiable. See the kink that generates problems for optimization. That's why cross-entropy or deviance is far more popular, because there is no kink, the function is smooth. As defined in the previous video, the cross-entropy is just the proportion times the logarithm of the proportion. And the only difference here is that we generalize for k classes. If you remember the previous video, cross-entropy is a measure between 0 and 1. See that in the graph we rescale the cross-entropy to make it comparable with other measures of impurity, like gene index. If you see the formula of gene index is very similar to the cross-entropy. They both have the same properties. Gene index is just a variance of a binomial process. That's why it is used as a measure of inequality in economics. A part of the advantage of a cross-entropy in optimization, let's see how cross-entropy is more sensitive to change in the node probabilities than classification error. Let's assume that you have 800 observations, 400 are dogs and 400 are cats. Suppose you have a variable that split the node in 300, 100, and the other side 300 and 100. Then the classification error will be 25%. Now let's assume the same example, but let's assume that the variable split the node in 200 and 400, and the other side 200 and 0. See that is the second side, it's perfectly pure. Whatever is a dog or a cat, they are perfectly classified. However, the classification error is still 25%. Doesn't matter if the one side of the tree is perfectly classified. By the other hand, the cross-entropy or deviance will be smaller than the classification error, because cross-entropy is sensitive to these node probability changes. But for the case A, because the split is symmetric, the cross-entropy and the classification error is the same.